what I would probably use a U-substitution on this one. So what's your U going to be? Good. So that means that du is 2t minus 1, which is dt, which is part of the problem, right? My pen is acting weird. Okay. So my u is 1, or the denominator. The numerator I get 1 du. When we integrate 1 over u, what do we get? Natural log absolute value of u plus c. So I put this t squared minus t plus 2 in there. All right. What else do you guys want to see?
Yeah.
You want to go in order?
Yeah.
All right. So you want to see the next one? Okay. 100% guarantee you're going to see something like this on the test. Okay? So, you need long division. Because a U-substitution isn't going to work. Because the derivative of x squared is 2x, and that's not part of it. And the derivative of x minus 1 is x, or dx, and that's still, we still have that x squared hanging out. So, the only way to take care of this is by using a long division. So how many times does x go into x squared? X. So distribute this through. What's x times x? Good. X times negative 1. And what are you supposed to do to the signs? Switch them. So these go away and we get x. All right. How many times does x go into x? Once. And then you distribute through and you get x minus 1. And then what do we do to the signs? Switch them. And then what's left over? 1. So I put 1 over x minus 1. That's what we now integrate. So now we integrate x plus 1, maybe, plus 1 over x minus 1 dx. All right, when we integrate x, what do we get? Good. And when we integrate 1, what do we get? X. And 1 over something is? In this case, the u sub would be just a dx, right? So we don't need to worry about it because it doesn't have a coefficient. So x minus 1 plus c. So that is your final answer right there. Oh, it didn't highlight. I was trying for the highlighter. Oops.
That one's going to be on the test?
That one will be on the test, yeah. Pretty much guaranteed. You'll see something like that. Maybe not that exact one, but something like that. All right, you want me to go in order is what you wanted? Okay. All right, what is this? What are we going to use for u? Pi x. So du is going to be what? Pi what? Dx. So I don't have the pi, correct? So I need to move the pi over. So you get 1 over pi du equals dx. All right, cosecant of u, cotangent of u. For the dx, I'm putting in 1 over pi du. When we integrate cosecant cotangent, what do we get? Negative cosecant, and instead of writing u, I'm going to write pi x plus c. I think I have a typo in my notes. All right, we good with that one? Okay. What do you think you're going to use for your u this time? Cotangent x. Because what's du then? Is that right? Yeah. So what's missing from the original integral?
Negative sign.
The negative sign, so we need to pull the negative over. Alright, so we rewrite the integral as e to the u, and then for the cosecant squared x dx, we put in negative du. When we integrate e to the u, what do we get? E to the u plus c, and instead of writing u, I'm going to write cotangent x. Yeah, the first four are not bad. Your first line of defense should always be U-substitution, right? Then you try the other ones. Okay, so on 16, U-substitution doesn't work. We are multiplying two variables together, so what do we have to use? Integration by parts. And remember, we have this little acronym for integration by parts. It tells us what to pick for our u. So in this case, what are we going to pick for our u? Good. Natural log of x. So that means that du is what? 1 over x dx. Good. That means dv is... Good. So v has to be... Good. That's an x to the 5th. Alright, so we've got to go uv. What's your u? Good. Your v? Good. Minus v, which is the x to the 5th. I'm going to go ahead and put the 1/5 out in front. So that's your v. And then du is... Good. What is this reduced to before I take that integral? X to the 4th. Good. X to the 5th over 5, natural log of x, minus 1/5 x to the what? 5th over 5 plus c. Probably the only thing I would do is make it 25 in the denominator. If that. All right. I will tell you that I really, really like 18. It's not that scary. So remember, the first thing you always try is what? U-substitution. What would you use for your u? Natural log of x, because du is... Don't I have 1 over x? Yeah, so it's just a straight U-substitution. So what's going in for the natural log of x? U. We're cubing it, and then to bring it upstairs, we need to make it what? Negative. Good. And then for the 1 over x dx, we're putting in du. All right, you get u to the negative 2 over negative 2 plus c. And then we don't like where that's at, so I'm going to bring it back downstairs, square it, and instead of putting in the u, I'm going to put in natural log of x. All right, are we good with 18? All right, 23. So we have a variable times a variable. So what do we have to use? Integration by parts. Okay, so we have the LIATE to help us pick our u. What would we use for our u in this case? x squared minus 1. So du would be 2x dx. dv is going to be what? So v is also e to the x. Good. Thank you. All right, so it goes uv. So u is the x squared minus 1. V is the e to the x minus the integral of v, which is e to the x, du, which I'm going to rearrange that a little bit. I need more space. So it's going to be 2x dx, right, for this piece. All right, I have a variable times a variable, so what do we need to use again? You got to use integration by parts a second time because I had a variable times a variable. So let me use a different color. So I'm doing another integration by parts on this chunk right here. So what's your u going to be? X. So du is going to be dx. dv is going to be e to the x dx, so v is going to be e to the x. So uv would be x e to the x minus the integral of v e to the x du, which is dx. All right, what are we going to do? At the same time I'm integrating, I'm also going to distribute in that negative 2, okay? So when I integrate e to the x, what do we get? E to the x. All right, plus c, right? We've got a negative times a negative 2 is going to be positive 2. And then I'm going to distribute the negative 2 into that term. So negative 2x e to the x. And then I'm just going to write this first term down the way it looks. All right, so what we just did there, we could have also done by the tabular method, which is what we're going to see in the next two. So if it doesn't tell you that you have to use a specific way, you can do it however you want. So I could do these tabular ones. I could do them with integration by parts. Tabular is just another way to do integration by parts. The key to tabular is you want to either see something with e to the x, cosine x, or sine x in it. That's when tabular works really, really well. Okay? All right, so to do tabular method, we had a table, and we said the first thing was we alternated signs. Then we had u and its derivative, and dv and its integral in that column. All right, so what would our u be? Still using LIATE. X squared, good. And I'm going to keep going. I'm going to do that. I'm going to do that column first because then I know when to stop. So I keep taking derivatives until I hit what? 0. Good. So what's the derivative of x squared? 2x, and the derivative of 2x? 2 and the derivative of 2? Good. All right. We're going to need to do e to the 2x as our dv. I do have a little U-Substitution there, don't I? So we'd have 2 dx, so I'm missing the 2, which is a 1/2. So all I basically need to do when I integrate is make sure I tack a 1/2 onto it, an extra 1/2 onto it every single time. So when I integrate e to the x, I get e to the x squared and 1/2 from the U-Substitution. When I integrate e to the x, 2x again, I get e to the 2x, and then I have 1/2 times another 1/2 would be good. I'm going to do it one more time. I integrate e to the 2x, I get e to the 2x. The 1/2, the 1/4 times the 1/2 again is 1/8. All right, then we need to alternate signs. We go plus, minus, plus, minus. And then remember on this piece, we read across, then down. Okay, and we're multiplying what on the diagonal there. So So I know it's a positive x squared times 1/2 e to the 2x. Then we're going to go across and then down. So when we go across, we get negative 2x, and then it's 1/4, so I'm going to go 2/4 e to the 2x. I can reduce that if you want to, the 2/4 to 1/2, that's fine. Alright, then I'm going to go across and then down, so I get 2, and it's actually 2/8 e to the 2x plus c, because technically you integrated. Again, tabular is just another way to do integration by parts. Take a pass. You're going to need it here in a few minutes. Oh, can you have it?
Yeah,
Postures. Let's see if I have. Alright. Okay. We good with 59? Okay, let's look at 61. So another tabular method to practice. We know it's good because it's got a sign in it. So we're going to alternate the signs. We're going to do u and its derivative, and dv and its integral. Alright, so what are you going to use for u on this one? X cubed. Good. So we're going to do x cubed. What's the derivative of x cubed? Good. And its derivative? And its derivative? And its derivative? Good. Alright, what's dv? Good. So now remember we're integrating. So when we integrate sine x, what do we get? Good. When we integrate negative cosine x, we get. We integrate negative sine x, we get. Be negative negative cosine, right? Which makes it positive. And when we integrate cosine x, we get. Good. And what sign do we start with? So plus, minus, plus, minus, plus. What's wrong?
Do you always start with positive? Or
yes. Every single time it starts with positive. Okay? It's just the pattern. Now, it's going to alter its pattern when we line it up on this one, right? Okay. So we're going to go across and then down. So when we go across, and then now remember we're multiplying, so I'm seeing negative x cubed cosine x because of the negative right here. And I'm going to just go across and then down, so I see a negative times a negative is going to go positive 3x squared sine x. Then we're going to go across and then down, so I'm seeing plus 6x cosine x. And across and down, and I get negative 6 sine x plus c.
Is that your answer? Do we solve?
That's the answer. Oh. The baby kept me up last night. And then at 3 I couldn't get back to sleep. Yes, it does. Don't have kids. At least till you're ready to lose sleep. I know you all value your sleep right now, right? Alright. So, this one, the first thing we always try when we integrate is what? U-sub. So what do you think you would use for u? Cosine x, so we've got du equals negative sine x dx, so what's missing? The negative. Alright, so I'm going to go u cubed for the sine x dx, it's negative du. When we integrate u cubed, we get u to the 4th over. Good. Plus c, and instead of u, we're going to write cosine x. Good. That's it.
I have a problem about the last one.
Oh, you have a question about the last one?
Yeah.
What's wrong?
Well, you said because there's sign, it's good for the tabular method.
For the what?
Because you said we see sign.
Either sine, cosine, or e to the x.
Okay.
And it's because it's things that cycle back and forth in their integration or derivatives that work really well for tabular. Okay?
I get that.
Yep, take the pass. Alright, let's look at 9. So 9 is one of these things where we've got to break it off. Okay? And I know a few of you were working on one of these last week. Okay? So this was kind of part of our little group activity last week, was something like this. So if I went and I took and broke off a sign, so that would make it sine to the 4th x cosine squared x sine x dx. And the reason I'm doing that is I don't do very well with odd powers, but even powers I can usually get into something squared, and I know what to do when I have something squared. So this one looks way worse than it is. If we have to do one like this one's not so bad. So another way to write sine to the 4th is sine squared squared, right? Sine x dx. Alright, if I was going to take that sine and try to turn it into cosine, what would we replace it with? What identity? Good. Cosine squared x sine x dx. Alright, squared means we FOIL that thing, right? So I really have 1 minus cosine squared times 1 minus cosine squared, right? So I'm going to FOIL that. What's 1 times 1? 1. 1 times negative cosine squared. And how many of those do I have? 2 cosine squared x. And negative cosine squared times negative cosine squared is? Good. Alright, what are we going to do with this cosine squared x? I'm going to distribute it in. So cosine squared x minus 2 cosine to the 4th x plus cosine to the 6th x. And then I'm going to leave just the sine x dx outside. Alright, what do you think I should do from here? U sub would be good. What would your U be? Cosine x, good. So du equals just sine? Negative sine, so we got to bring the negative over. So negative du equals sine x dx. Alright, let's sub in. So I get u to the 2nd minus 2u to the 4th plus u to the 6th. And then for the sine x dx, we get negative du. Alright, so we got a negative hanging out in front. And we've got u to the what? 3rd over 3 minus 2u to the 5th over 5 plus u to the over 7. And we've got cosine x, cosine x, cosine x. I can distribute the negative if you really want to. Oh, don't box it, right? Alright, we're good with 9? All right, looking at 25. What do you think we need to try first? U-substitution. So what's your U? Sorry, I'm in the wrong problem. Well, your U is the 3x, so du is equal to 3dx. Do I have the 3? No, so I need to put that in there. So we're subbing in, so I get secant of u, and then for the x is dx is 1/3 du. Alright, if you don't remember this one, I suggest looking on the back side of your yellow piece of paper. So when you integrate secant, what do we get? Tangent u plus c, and then what am I going to put in instead of u?
Yes.
Good. Thank you, Greg. All right, we good with 25? All right. Actually, this one has a u too, because we always try U-substitution first, right? Even though it could be an integration by parts, but we're going to try U-substitution. So, what is your u, do you think? Tangent x, so du is what? Secant squared x dx. So for the tangent, I'm putting in u. For secant squared x dx, I'm putting in du. Alright, when we go to integrate, we get u to the what? Squared over 2 plus c, and instead of u, we're going to write in tangent x. I know, that might be too easy for the test.
No, I think that one's good.
No, you think that one's good?
Yeah. You should
Okay.
have like 5 of those on there.
You should like have the whole test on.
Or the whole test on that problem?
Yeah. And then it's like throw in integration by parts and we'll call it.
Integration by parts and we'll call it good. Just 2 questions.
No, see, it'd be so easy.
Last period wanted me to do 1 question all or nothing.
Huh?
Yeah, no. Okay, so I think if you look at page 61 in your notebooks, so if you have your notebook out, page 61 has the formula on it. I may give you a trig chart tomorrow. I'm contemplating that, okay? Because this is a product to sum. You have to convert it into a product to sum first and then integrate it, okay? I think, like I said, I think it's on page 61 of your notebook. So, and what you're looking for is the product to sum identity. Alright, so when I start the product to sum, I get what number out front? 1/2, good. And then what do I get in here? Sine, and you're supposed to add or subtract. Subtract, so what do you get? Sine what? X plus what? Sine, and you add or subtract? Add, and you end up with 5x dx. So I'm going to choose to separate it into 2 separate integrals. And I'm going to move that 1/2 over both of them. Alright, when you integrate sine x, what do we get? Negative cosine x. Okay, now I need a U-substitution over here, don't I? Yeah. So what is the u? 5. So u equals 5x, which means that du equals 5 dx. So you've got 1/5 du. Alright, so 1/5. So what's 1/2 times 1/5? I don't really need to write out the whole u, right? I could just add in the 1/5. So when we integrate sine, what do we get again? Negative cosine of the 5x plus c. All right, we good? looking at 21. Now, this one probably came out of the trig substitution. However, we don't necessarily have to do trig substitution to do all of these. Okay? Though we did discover on some of them that trig substitution was easier than memorizing our arc integrals. So, it's a way to go there. What do we always try before we would try a trig sub? A U-sub. Does U work this time? What's the derivative of that? So can I use U-sub? Sure I can.
Just kidding, yes you can.
Yeah. Alright. So let's try it. I put U in for the x squared minus x squared plus 9. It's the 1/2 power. How do I bring the 1/2 upstairs? Negative. And then for the x dx, I put in 1/2 du. Alright, when we integrate u to the negative 1/2, we get u to the 1/2 divided by 1/2 or multiplied by 2 plus c, and instead of u I'm going to write x squared plus 9. If I was going to simplify this for multiple choice, these guys would go away, right? And then square root of x squared plus 9 plus c. Alright, looking at this one. So, if you had your arc integrals memorized, you could use that. Let's say you don't have them memorized, which I'm going to guess is about 90% of you. Okay? You do need your yellow chart, which I said you can use your yellow chart on the test, right? So you're going to get a different one tomorrow. Alright, I'm going to provide your yellow chart again, so you don't, so that way, huh? Why? So you don't write on your yellow chart, right? So no writing on, so I will have a yellow chart for you, okay? Alright, so yeah, it's not worth even taking notes on it, right? Okay, so we need to decide which one we have. So it is the number minus the variable. So which row of your yellow chart do you have? For the sign row. Okay, so let's figure out our A and our U. So what's your A part? 4. And your U part is? X. And then we've got the triangle. So what goes on the hypotenuse?
4.
Good. And what goes on the opposite leg? X. And then on the adjacent, the radical. Then the next thing we do is we set up our formula. So we have a U formula which we plug X into. So it's X equals what? 4 sine theta. And what are we supposed to do to that? Derivative. And what do we get? Cosine theta d theta. Then we set up our radical formula. What's 4 cosine theta? Good. Now we're going to sub in. So for the square root, I'm subbing in 4 cosine theta. For the dx, I'm subbing in 4 cosine theta d theta. What's going to happen? Cancels, and I end up integrating just d theta. When I integrate d theta, what do we get? Theta plus c. So here's the downside. We don't need the triangle, because I can't just read theta off the triangle. So I kind of did more work than I needed to. But here's the thing. Instead of having to memorize an arc, I can just solve this, can't I, for theta? So if I'm going to, how do I move the 4 to the other side? Divide it equals sine theta. And then how do we undo a sine? You arc sine it, right? So we're going to arc sine both sides. Arc sine, arc sine. So you end up with arc sine x over 4 equals theta. So I'm going to plug that into theta. So arc sine of x over 4 plus c. Alright, we good with 23? Yeah? Alright, 27. We have 2 more. You guys are quick. What did it cost? Ran out of time. Okay, so I've got a variable time minus a number. So which row is that? The last one, the secant row? So what's your A going to be? 3, and what's your U going to be? X. Let's set up our triangle. Alright, what's going to go on the hypotenuse? X. And on the opposite leg? The radical. Minus 9. And then on the adjacent leg? 3. Good. Alright, so we've got X equals what for your U equation? 3 secant theta, and then dx equals 3 secant theta, tangent theta, d theta. Good. And then the radical equals what? Yeah, we're not worried about the plus minus part of it. Okay, so we go to integrate this, or we go to sub in. What do I put in for the radical? 3 tangent theta, and then for the dx I put in d theta. Good. And what happens? The 3's cancel, so I'm left with secant theta d theta. Here's where you go look at the back side of your yellow chart. Okay, when we integrate secant, what do we get? And then here's where the triangle comes in, right? So secant of the triangle, remember you've got SOHCAHTOA in the front of the room. Secant of the triangle is what? So x over 3, and then tangent is going to be what? So square root of x minus 9 over what? 3 plus c. Alright. 43 is all kinds of fun. We have to complete the square first. Okay? So this one's a little bit strange. I'm going to do a little bit of manipulation with it before I actually do the problem. So the first thing I don't like is I don't like the order for completing the square, so I'm going to rearrange it and pull out a negative, and then I'm going to have to switch it back. Okay? It just doesn't work for me for completing the square. So I'm going to start by pulling out a negative. And I'm also going to switch the order. So I'm going to switch it to x squared minus 4x. Notice the negative is still under the radical sign. Alright, now I'm going to rearrange it again. I'm going to get my blanks in there. And remember, whatever I add, I also have to subtract. And it's all under the radical sign. Alright, and then I'm going to set up for my cheating factoring here. I've got my radical. This thing here. I need kind of double parentheses. Okay, so to complete the square, I do what with the negative 4? Divide by 2, what do we get? And then we do what with the negative 2? Your hint's right here. You square it, so we add 4 and subtract 4. So what we have done at this point is we've taken this piece and it's just this. So I'm missing, see how I'm missing that minus 4? So I still have to put the minus 4 on the end of it. Alright, the next thing that I'm going to do is I'm going to take this negative and distribute it back in. So what's it going to do to the 4? It's not going to cancel. What's negative times a negative is positive 4. I'm going to put that up front and then minus. Because remember, I'm distributing it to the binomial too. Now I am finally ready to integrate. That was ugly. Okay. So there are two ways you can do this one as well. If you have your arc integrals memorized, you can do it that way. Or we can do trig substitution. I'm going to go ahead and do the trig substitution. So, what is your a value in this case? 2. What's your u value? Good. Okay, then I set up my triangle. I have the number minus a variable. So which row is that? It's the secant row? Are you sure? It's the sine row, isn't it? Okay, so what's going to go on the hypotenuse? 2. And on the opposite leg? Good. And then on the adjacent leg? Radical, so 4 minus x minus 2 squared. Alright, so I've got the u is going to be x minus 2. What's going to go on the other side of that equation? Good. And then we have to take its derivative. The derivative of x minus 2 is dx. What's the derivative of 2 sine theta? 2 cosine theta d theta. Alright, and then we've got our radical equation is going to equal what? 2 cosine theta. Alright, so I'm going to kind of come in this box here and finish it. So I'm going to go from here and sub in. So my radical, I put in 2 cosine theta. For the dx, we're putting in 2 cosine theta d theta. So do you see how everything canceled? Because I told you this is one that we could have had memorized, right? But if we don't have it memorized, this is the way to do it. Okay, when I integrate d theta, what do we get? Theta plus c. And then, can I solve one of those for theta? Yeah, again, this is the long way to do it, but it's possible to do it this way. I'm going to solve for theta. How do I move the 2 to the other side? Divide it, so 2 equals sine theta. And then how do we get rid of the sine? Arc sine both sides. So that way it cancels here. So for the theta, we're putting in arc sine of x minus 2 over 2 plus c. And that's it. Alright, so I will still stamp homework later this week. If you really, really want me to see it right now, that's fine. Okay? Wednesday's messed up. I'm not expecting you to have any brain power by the time I see you. Okay? Because of the SATs. Huh? Notes, I'm not going to do notes this time. Okay? All I want you to do is focus on studying for this test. Okay? Don't worry about your notes this time. Thursday we will try to do some kind of lesson. Friday apparently we're getting hit with an avid field trip, so we will deal with that.